Behind me is a post-tension engineered foundation. This is the most common foundation you will see here in Texas. We actually on this job site have two different types of foundations. We have a post-tension and we have a rebar foundation for a barn we're building. So what I'm going to first do is go over the foundation for the house and guest house that are both post-tension. So what that means is the form boards are initially set, which are the footprint of where the house is going to go. In the case of this house, we did something that not all foundations will have that are done like this, but this one does, which are foundation piers. So on this kind of foundation, they can be poured without foundation piers, or if we feel that we are either have bad soils, or I should say very unstable soils, or we have used a lot of fill dirt, which may not be as compacted as the old naturally compacted dirt, and there's a chance it could settle with rain and whatnot, we will use foundation piers. Foundation piers are essentially holes drilled with rebar in them. Unlike a pier and beam house, which actually means the piers are poured and left above ground and then wood beams are put across them to create your first floor. Here in Texas, our foundations are all concrete. Your first floor has no crawl space, none of that. And it does get confusing if you come from the Northeast and you've had that kind of foundation. But here, the pier concept's the same, hole drilled, but what it's meant to be is reinforcement for settling. We had to add fill dirt at the back, and this one has an attached guest house, so it gets very deep. And as the slope of the lot is falling away, we bring in dirt to build it up. These are called slab on grade because they have to be perfectly level all the way across. So here we have a huge foundation from back to front, I think is 150 feet or something like that, and it has to be perfectly level all the way across. The ground is not perfectly level, so we have had to put fill dirt on the back. For that reason, we engineered foundation piers into this foundation. The engineer designs that for us. The piers hit all around the perimeter where the beams intersect and where the beams intersect on the inside of the foundation. Form boards are set, and then the pier truck comes out and drills everywhere it's marked for foundation piers. I'm going to turn the camera around and show you what a foundation pier looks like. So what we are looking at here is what we call a beam, the deep trench, and right there where these two beams intersect, you see the top of concrete. Okay, let's turn the camera back around. So what you are seeing there is a pier that's been drilled, I think it's 20 feet roughly here, filled with rebar and concrete, and then it is left at about the elevation of the bottom of the beam. So what happens is all of these piers are throughout the home where all these beams intersect. The foundation then gets poured on top. And those piers are a reinforcement against settling. So let's say that fill dirt in the back of this lot isn't 100% compacted, and this is a good example of that. We are in Texas, 100 degree weather. The dirt is dry when it's brought in. The excavators use a compacting machine, they use water, they do everything they can to compact that dirt, but it's not the same as this pasture behind me that's been compacted naturally for millennia, right? So let's say that fill dirt back there after a bunch of rain and everything, there's a little air pockets, that ground starts to settle a little bit and the foundation wants to settle. It's sitting on top of these piers, which will prevent it from dropping. So that's all we use piers for in these scenarios. They're just solely a reinforcement against settling. You know, if you just built the slab on top of that fill dirt and the fill dirt did start to settle a little bit, the slab would go with it. With these deep piers, it's not going to go anywhere. So that's the very first thing we do. The next thing after the piers are done is the rough plumbing. And I did a video on that already, but as we can see, let me turn the camera around again. We've got drains, we've got vent stacks. This is a good example over here of where we have a kitchen. And so that should be an island right there. And what they've done is over where the actual wall's going to be, they have the piping where they can run everything they need down the wall under the slab and up where the island's going to be. So this is an example of a floor plug setup right here. So what we are looking at is a floor plug. One there, one there. That blue, what we call Smurf tube, goes over to where a wall will be. So the wiring will run down the wall and to these floor plugs. After the ground plumbing or rough-in plumbing has been put in, which primarily consists of drains in the foundation. We don't really run any water in the foundation except for these couple areas where we have kitchen islands and water has to go down a wall through the slab and up where the island's at. Otherwise, we run all of our water overhead after the house has been framed. So all we end up with in these foundations are some drains, some conduit for floor plugs, things like that. After the plumbers are done, we send in what's called the grade crew. This is the concrete crew that actually comes in and digs all these beams, these trenches that you see behind me. After they've dug it in the right locations per the designed foundation plan to the depths that it's supposed to be, they then come in, put all of this plastic, this poly, over top. This is a water barrier, and it's not used at the bottom of the beams, but it is used in these shallow 4-inch sections of the foundation. So you get all this plastic, then on top of the plastic, they put in the post-tension cables. And so let me show you how a post-tension cable works. I'm going to turn the camera around here. So what we've got, right here you'll see a cable. A little hard to see in that. Let's look at these here. We call these live ends. So these are the ends that stick out of the foundation. They are rebar, then encased in a plastic cable. And these are the ends that they will come back and put tension on later. Right now, you'll see the cables run across. In the case of this particular beam, you've got one running up at the top, you've got two running down in the bottom. This is an example of a reinforced area that has both cables running through it and a lot of rebar for reinforcement of an area where you could have heavy brick, stone, things like that sitting on it. Okay, so this foundation is completely made up now. It just got inspected by the engineer. As a builder, we don't design the foundations and we don't say they're okay to be poured. An engineering firm, structural engineering firm, designs the foundation based on the home design and then comes out and inspects it, tells us we have dug the beams deep enough, everything is set up the way it's supposed to be set up. At that point, we can then pour our concrete. So this thing is ready to pour. All these other form boards, if we can see them here behind me, are showing separations where the front porch is in this case, because it's going to be dropped down a little bit and it's going to have fall or some slope out towards the end because you want when rain hits to run out and off the slab. Same with the way the garage is set up, back patio, all that's been done. So at this point, this slab is ready to pour. Now, going back to those post-tension foundation cables, I just showed you what we called the live end. So after the foundation is poured, about a week or so after, guys will come out with hydraulic machines attached to those cables and they pull and put a tension on them. They're encased in concrete that puts tension on the foundation. That's why it's called post-tension. It happens after the foundation is poured. It puts a level of tension on all the concrete that helps distribute the load better and deals well with our expansive soils that we have here in Texas. So when we talk about expansive soils, it just means we have a lot of clay content and the soils tend to expand and contract with moisture levels. So as we get rain or in the summer when it's dry, we start to see cracks out in the ground, and that's because the dirt is contracting. It's pulling away from itself. It's shrinking. So what I'm going to show you here, let's turn the camera around. These are the dead ends of these cables. Okay, what this means is that we do not see cables sticking out of this end. This cable will be encased in concrete on this side, and then when it runs all the way over, we're looking at that group of cables with the live ends on that side. That's what the guys come out with the hydraulic machine and put the tension on it. So you only have one live end depending on which way these things are running. I think we've got the live ends of these cables running that direction over there. And then as we go that way, they would be the dead ends, or the section that's encased in the concrete. So I'm over here at the primary bathroom, and here we can see plumbing. This is where we have formed up the shower, so it'll be a recessed shower that drops down. They build the shower out of the form boards, and then that section of concrete will be shallower. We've got a tub behind us, and this is a section the plumbers come back before we pour. They've already done it, but they call it box and wrap. So again, turn the camera around. What we see here is that's a drain. This is where water's coming up. And so by using these boxes, it allows them to move the drain around if they need to center it when we finally come in with the tub. They also are wrapping sections of pipe. So here's an example of a shower drain. The shower drain is over against the wall because it's going to be a linear drain. So that's the type of drain where the foundation, the tile is all sloped to the wall, and there is a linear drain at the wall. So I'm piecing this video in. I was standing here a couple days ago showing you how it looked before it was poured. That is the tub. Here is that primary bathroom shower, so it's been recessed with that drain against the wall for the linear drain. It does have the box, so if they need to move things around a little bit, they can. So another feature of a foundation when you're looking at them are the way we design them if they are going to have a masonry exterior like real stone or brick, or if it's a siding or stucco scenario. So what we will do is anytime we have a stucco or siding area, we will basically frame the walls right at the edge of the foundation. So here's an example. The foundation is poured right to here. The framed walls are right there, and all of our stucco or siding will be more or less flush with the foundation. As we move over here, all of a sudden you see a board sticking in. You see, you don't see it on any of this part of the foundation, but then all of a sudden there's another board laid sideways. That is what we call a brick ledge. So what we're trying to do is give a 5.5 inch gap between the edge of the slab and where the framed wall starts. It will be lower because if you think about the thickness of that board, the concrete will end up at a slightly lower level than the rest of the foundation, and that is where we set the stone or brick. So this house has a brick ledge running, let's see if I got the angle. There we go. Brick ledge running on this part, the side of it, some of the front of it. And so this house basically has a combination of spots on the outside facade that will be stucco, where we will frame the walls right to the edge of the foundation. Other areas like the front here where we've got stone, brick, things like that, and we have created a section with the foundation that gives us 5.5 inches. You're going to talk about brick or stone generally being about 4 inches thick, and so you want to have some space between the masonry and the sheathing that we use on these. Sheathing being the plywood on the side, and we do use the green stuff you see called zip wall sheathing, which is a laminated sheathing, basically has a house wrap laminated to it. And then you'll see, as we talked about, when the form board's pulled away, that's the edge of the foundation. The framed walls will sit right on the edge, and the stucco goes against that. But this is that section I was showing as we go towards the front, where there had been a board here. Now we have a brick ledge. So the edge of the foundation is 5.5 inches into where it raises up. So basically what this does is allows the masonry to sit on that ledge and be a little bit below the finished floor grade of the house. That way water can't crawl up over the slab. So that is that, by the way, is a strap to hold the framing in place. And so all the front of this has stone on it. So we have a brick ledge running along here. Now this project is interesting because I mentioned It's got a big house you can see behind me, and those are the videos I just shot about post-tension foundation. And then it actually has an attached guest house, which is right behind me here. When I say attached, it is not structurally attached with foundation. It will be with framing because it has a breezeway, so kind of a unique setup. But basically here, between the two, we're going to have a breezeway. Let's turn the camera around and show you how this is done. Half of it is not formed yet, but it has dowels, which are pieces of steel that are doweled into the other foundation. So this is going to be almost like what we call flat work, thinner concrete. It's not meant to be engineered foundation. It's doweled into each foundation so that it will not heave on its own. It is tied to these foundations, but it is not part of either engineered foundation. So what we have here is just, see if I can give a view. This is the guest house. So I think this is close to 1,700 square foot of semi-attached guest house. Also a post-tension foundation with foundation piers. So we have the foundation piers in here also. All of the drains from both the guest house and the main house end up tying together, and they just exit in one place we call the sewer drain exit. So these are two cleanouts. One allows you to go back towards the house, the other to go towards the sewer, in this case the septic system, with plumbers if they ever need a router, anything if we've got blockages. But all of the drains in this foundation merge into these sewer exits here, and they go out to a septic tank that is not in yet, but will be. One of the interesting things about this project is it also has a big party barn. It's really going to be a steel framed building with some wood framing on the inside because it has a couple levels. So now I'm coming up on the party barn. You can see behind me the house. And here's the foundation for the party barn. Now, it is essentially a huge rectangle because as metal buildings are, it's a big structure. It will have 2 floors inside of it. The interesting thing when you're looking at this foundation is it looks just like the house foundation. And it is waffle style with foundation piers. The only difference is this is a rebar foundation, meaning the only steel reinforcement in it is rebar. There are no post-tension cables. So there are no cables sticking out through the form boards here. The crew that puts the tension on the foundation cables will not touch this because there are no cables for them to have to put tension on. Basically, and let me turn the camera around, this just uses rebar as the reinforcement method. It is also designed by an engineer, and a matter of fact, he was just here inspecting and just left a minute ago. You only see one area where there's other form boards, and that's because there is a garage area there, which is going to be separated from the rest of this, but otherwise, same thing as the house foundation, just reinforced with rebar, all rebar instead of post-tension cables. This type of arrangement with the party barn being back behind what's already a very deep house is unique when it comes to the sewer and the water. The water is tied to the house itself. The sewer is interesting because when I was showing you the sewer exit on the house, that all uses gravity to flow to the septic tank. So the septic tank will be placed lower than the sewer exit pipes, and everything uses gravity to drain to the septic system. But back here, we are a little bit downhill and we have way too long of a run to even get to the house. So I'll walk over here and show you the same setup. Here is a sewer exit. Right there. So this does have a bathroom, some sinks. We've got a drain for what's called the ATV garage back here. And so same thing, everything drains to one sewer exit location. What we have to do then is use a sewer pump. So a pump will be placed here. It's been covered over with dirt already, but there's a sewer line that runs all the way up to where our septic system will be. And basically all the sewer water fluid from this party barn will be pumped to the septic system. So this is a Thursday as I shoot this. Everything's been inspected, ready to be poured. We can't get concrete in the pump until Saturday. So they're going to be out here to pour the foundation on Saturday. I'll document that also. After we pour the foundation, we let it sit for a week before we get our framers on it to start framing. That gives it some time to cure. Within that first week, it is going to have, reached substantial PSI, and it does take about 30 days for the foundation to actually cure out, but we like to give it 1 week before we start framing on it. So this is the rebar foundation of the party barn, mostly poured. We have a huge boom truck here that is essentially a concrete pump. So what's happening is the concrete trucks dump into the back. It is pumped through this boom, and they swing it to wherever the concrete finishers need concrete at this foundation. With these pump trucks, there's a operator that actually uses a remote control to steer the boom. I hope you guys appreciated this video about foundation construction, as well as getting to see it when it's actually being poured. This is just 2 days after I shot all the other videos showing the inside pre-pour. So again, hope it's helpful for you. I'm going to be documenting this build as it moves along, so there will be plenty of videos from this site. But I hope this video was helpful for anybody interested in slab-on grade foundations like what we do here in Texas, post-tension and rebar. Again, appreciate you watching. You guys take care. Click like and subscribe for me, and we'll see you soon.